So, imagine this. Your company's most important pricing decisions, the ones that drive revenue, are being guided by data that's silently, invisibly going bad. It's a terrifying thought, right? Well, in this explainer, we're going to break down a real-world case study of how one team discovered a hidden data gap just like that and engineered an absolutely ingenious, zero-risk solution to fix it, all without touching the legacy system that caused the problem in the first place.
Okay, so where does every data project start? With a business need, and this one was about as critical as they get. They needed flawless pricing analytics. The company had to pull data from their core Oracle system into a modern data warehouse. And listen, this wasn't just for some fancy reports. This was the bedrock for major revenue decisions, pricing validation, even financial reconciliation. A mistake here? We're talking millions of dollars on the line.
At first glance, the data pipeline looked great. It was modern, it was straightforward, but the whole thing was built on a very common technique called change data capture, or CDC. The idea is really simple. You only copy data that's actually changed since the last time you checked. And the entire system was built on one single assumption, that any change to a record would update a timestamp, this little field called last update date. It's the foundation of most data pipelines. It's logical, it's industry standard, and in this case, it was completely and totally wrong.
It wasn't long before the team knew something was off. The reports just looked inconsistent. The numbers weren't lining up with what was happening in the real world. They realized that deep inside this massive, complex legacy system, a silent villain was at work, corrupting their data without leaving a single fingerprint.
This visual here explains the problem perfectly. Think of it like you have two conveyor belts. The top belt, that's the normal process. A record gets updated, boom, it gets a last update date timestamp, and the new data warehouse picks it up. Easy. But there was a second, hidden conveyor belt. A legacy custom program was running on the separate track, and while it was updating critical pricing data, it was completely bypassing the timestamp process. So those changes were totally invisible to the new analytics system. It was creating this silent, growing, and incredibly dangerous data gap.
And let's be clear, this wasn't just some tech glitch. This was a full-blown crisis of trust. The pricing reports, the whole reason for the project, were just flat out wrong. The analytics team, the folks who were supposed to be the source of truth, they started losing credibility. And the worst part? The finance department was flying blind, at risk of making major revenue decisions based on bad data. The entire system was failing its most basic promise.
Now, you're probably thinking, okay, just fix the old code, right? Simple. But this is the real world of enterprise IT. The architects basically found themselves engineering inside a straitjacket. They were facing this rigid set of constraints that made any normal, conventional fix totally impossible.
And this slide lays out those constraints perfectly. First, the business had one non-negotiable rule. You cannot touch the legacy source code. 0 changes. It was a black box. Second, a super strict security policy meant there was no way to create a direct database link between the old system and the new one. And third, to top it all off, the scale was just massive. We're talking about 14 million rows that had to be processed, flawlessly, every single time they ran the job.
So this became the million-dollar question, right? How in the world do you fix a data gap in a system you are forbidden to modify that you can't even directly connect to, all while handling these huge data volumes at lightning speed? Honestly, it seemed like an impossible problem to solve.
The breakthrough, when it came, didn't come from some more complex tech tool or from throwing a bigger server at the problem. No, it came from a fundamental pivot in their thinking. It was a shift away from relying on brittle technical details and toward embracing the solid, durable logic of the business itself.
See, the old way was totally reliant on that fragile technical timestamp. It was always asking the question, what data changed? The new solution was built on something much stronger, business logic. It started asking a much smarter, more powerful question. What data is currently relevant to the business?
And that right there, that was the key insight, the aha moment. The team went and talked to the business users and they learned something crucial. You could only update a price list if that price list was active. That meant the active flag field was a perfect, unbreakable proxy for data that was relevant and might have changed. It was the reliable source of truth they had been searching for all along.
Okay, so with this new strategy, the team could finally identify the correct data. That's a huge win. But they still had to figure out how to move 14 million rows of it twice a week without bringing the system to its knees. And that required a really clever, layered series of optimizations.
What they ended up with was this really elegant three-layer stack. Layer 1 was all about the source system and the logic, making sure they touched as little data as possible. Layer 2 focused on the pipeline and the network, basically maximizing how fast they could move the data. And Layer 3? That handled the target and deployment, with one goal in mind: zero downtime for the business.
Now, Layer 1 was a total game changer. Instead of pulling these massive raw tables across the network and then filtering them, they pushed all the filtering logic back to the source system. By doing the heavy lifting on the source side first, they created a much smaller, way more efficient chunk of data to send over the network. And from a business perspective, this is huge. It slashes your network traffic, and more importantly, it dramatically reduces your processing costs in the expensive downstream data warehouse.
So this is where the real detective work came in. The initial performance was just awful. It was taking nearly an hour to move less than 1 million rows. The team realized the bottleneck wasn't the database at all, it was the network. The system was making all these tiny little data requests. It was like trying to fill a swimming pool with a thimble. So they dug in and found one single parameter, the array fetch size. They cranked it up from a default of 30 all the way to 4,000, basically widening the data pipe. And the result? A massive 7 to 8 times performance leap. Just like that.
And finally, Layer 3 was all about eliminating risk for the business users. You can't just take the pricing reports offline for hours while you load new data. That's a non-starter. So they came up with this brilliant temp swap strategy. Here's how it works. First, all the new data gets loaded in the background into temporary tables. Meanwhile, the live tables are still up and running, serving reports as usual. Then, once that 2-hour load is completely done, they perform a near instantaneous swap that takes only about 3 or 4 minutes. This whole approach separates the heavy lifting from the live system, and it absolutely guarantees zero reporting downtime. It's a lifesaver.
And look, the results just speak for themselves. Before this fix, below time was over 7 hours. Afterwards, it was down to 1 hour and 40 minutes. Throughput went through the roof, from about 18,000 rows per minute to over 150,000. This didn't just fix a problem. It transformed a brittle, slow process into a rock-solid, production-grade, scalable architecture. Let me just put that plainly. That is an 8x performance improvement. This isn't just about fixing a broken report anymore. This is about creating a reliable, high-speed data foundation that the business can actually trust to make its most critical decisions.
So, what does this all mean? What's the bigger picture here? Beyond this one specific case, what are the core principles that architects, technical managers, and even business leaders can take away and apply to their own systems to reduce risk?
Well, it really boils down to 4 key principles for anyone managing data systems. First, you have to validate your technical assumptions. Never, ever blindly trust that a legacy system works the way you think it does. Second, prioritize business logic over technical metadata. Business rules are often way more durable and a much better source of truth. Third, push work to the source whenever you can. Filtering your data early is the single best way to cut costs and boost performance. And finally, abstract the risk. Design your system so that the heavy data processing is completely separate from the live user experience. That's how you guarantee availability.
And that really brings us to our final thought. This entire incredible journey started with one flawed assumption about a single timestamp field. It really makes you wonder, doesn't it? Where might a similar silent villain be hiding in your own data architecture right now, just waiting to compromise the critical decisions you rely on every single day?